And hello all, it's Mr. Callen here to help you with another glance at Chapter 5, Lesson 4, the Distributive Property. Now, we've been doing this for a while. In fact, we've been talking about simplifying expressions, keyword here being simplify, make simpler, right? It would be great if we could evaluate, find the final value of everything we did, like what we've been doing with substituting in a number and getting a final value numeric answer. But sometimes there is some mystery involved and you just can't figure it out. Okay, well, at least let's try to simplify it. Now, sooner or later, we're going to get even tougher and review both distributing and combining like terms. But for today, we're going to focus more just on the distributive property. Now, kick back to some notes. In fact, I would suggest those of you might want to hit pause, get your notebooks out if you have some notes on or around November 2nd, where we discussed what distributive means and how to do so. But I'm wondering if you really truly understand it. We did some drawings, we did some pictures, but let's talk about why the distributive property works. So let's look at this problem. 3 times parentheses 2m minus 6, close that parentheses. Now I think we'd all agree what 2m's are. 2 envelopes full of money, don't know how much money is in each. And then we got negative $6. And of course that 3 out in front, it does not mean $3 bills. It means 3 groups or sets of 2m's minus 6. Now, naturally, when you do those 3 groups, why write 3 groups of 2m's when you can do 2, 4, 6m's? And why write 3 groups of minus 6 when you can do 6, 12, 18, excuse me, we'll call that negative 18. All right, if you feel so comfortable with that, I wonder how you'd feel drawing this. Look at how those problems are similar. They have same terms, 2m's minus 6's. They have groups. But I wonder how many of you would like to sit there and draw out 43 groups of 2m minus 6. I'll go ahead and start. That's 3 groups, and then we get to 4. There's 5 groups. There's 6 groups. There's 7 groups. Don't worry, we're almost at 43, right? There's 8 groups. Okay, do you want me to stop yet? Good. I'm going to write a dot, dot, dot. Because we don't want to sit there and draw out 43 groups. But I do believe that you can use your number sense and your algebraic reasoning to say, all right, I don't have to draw these out to know how many m's we're going to have. See, we have not 1 group, not 2 groups, not 3 groups, but 43 groups of 2m's. Why not just say 43 groups of 2m's is, you guessed it, 86 m's. Could we draw them all out? Sure. Do we want to? No, not when algebra skills let us do it more efficiently. Oh, hold on, Mr. Callen, hold on. We also will have not 1 group of negative 6, not 2 groups, not 3 groups, not 4 groups, but 43 groups of negative 6. Negative 6, negative 12, negative 18, negative 24, all the way to negative 258. Imagine drawing that model. So again, it's not impossible, but can we use the distributive property to multiply? Why are we multiplying? Because we have repeated sets. In this case, 43 sets of 2m's and 43 sets of negative 6's. That, ladies and gents, is a visual representation of why we multiply, and shoot, that saved us a load of time. Now, let's go ahead and take out your worksheet, the distributive property, lesson review, and homework practice. We're going to do a couple of these together. So let's begin. In fact, let's do some odd problems together, leave the evens for you to work on your own. Can we use the distributive property to evaluate each expression? Notice these have only numbers. Now, I know many of you are going to be tempted to compute the parentheses, but that's not what the directions ask. Directions are asking, okay, can we use the distributive property? Can we write 3 groups of 2? Well, sure, 3 groups of 2 is 6. What about 3 groups of 8? Well, 3 groups, 8, 16, 24. And it asks us to add together those 3 groups of 2 and those 3 groups of 8. Naturally, 6 and 24 makes 30. Now, if you do it correctly, you should get the same answer as using your parentheses, but we're not going to use our order of operations here. It's asking us to use the distributive property. So let's do that again with number 3. Number 3 tells us 5 groups of 4, which is 20. It also tells us 5 groups of -2, which is -10. Wait a second, Mr. Collin, hold on. This doesn't just ask us to take 5 groups. It asks us to take 5 groups and then take the opposite of all those. So the opposite of all those positive 4s would have been -4s, -4, -8, -12, -16, -20. The opposite of all those -2s would become positive. So that opposite symbol is going to change things up. -20 plus 10, go down underwater, go back up, but we are still underwater, not as deep, but we're at -10. Now pause if you want, rewind, listen to that again, and then I will invite you to complete numbers 5 and 7. Pause the video, come on back to me when you're ready to check your answers for 5 and 7. And so here we go. A groups of 10, A groups of -4. I'm going to change that to add the opposite. Final answer 48. 4 groups of -7 and 4 groups of +3. Pause and check your answers, check your work, go back and fix and learn from your mistakes. As we continue on, let's again use the distributive property. Notice we're not asking you to draw models. Let's go ahead and rewrite each expression. So I'm going to do this the long way. And instead, no, I'm not going to write 6 groups of T and 6 groups of 2. What I am going to do is write with numbers and symbols 6 groups of T and then another 6 groups of 2. Now 6 groups of T is 6 T's, 6 groups of 2 is 12. Can I combine those to make 8? No, those are not like terms. One is a variable term, which is a mystery. We don't know how much money is in those envelopes. But we do know this is $12, so that is as simple as it gets. But at least we've simplified it. No more grouping symbols. Let's carry along to number 11. We have 3 groups of 5. Excuse me, Mr. Collin, that would be the opposite of 3 groups of 5. And then we have the opposite of 3 groups of 7 V's. The opposite of 3 groups of 5, -15. Opposite of all those positives would be negative. Doesn't matter who's bigger. The opposite of going up repeatedly is to go down repeatedly. And speaking of the opposite of a positive, we're going to have -21 B's. And again, that is as simple as it gets. Although to really get you ready for algebra class, almost always in 9th grade algebra class, you'll write the variable term first and the constant term second. This is a good answer. This is a great answer. All right, head to the back side, please. Pause if you need. Rewind, re-listen if you need. If I'm going too slow, fast forward. Number 13 and 15, take a moment, please. Complete numbers 13 and 15. Pause, come back when you're ready. Either of those acceptable answers. Some of you will simply write subtraction. Others of you will write add the opposite. Those do mean the same thing. The strongest of students can write that in both ways. Now let's take a moment Check your answers, fix any mistakes, and let's go on with number 17. So some of you are wondering, how am I ever going to use the distributive property? And actually, you might use it out at the store and not even realize it. Take a moment, read number 17. Come on back when you're ready. Cost per person, $5.80. 4 members in the family. How much does it cost? And justify it with the distributive property. You know what that means, folks? That means we are not going to go off to the side of our paper and multiply $5.80 times 4. No, no, no. We can do this using the distributive property. 4 sets, or should I say 4 groups of $5.80. I wonder if I can make this a little easier mentally. See, $5.80 awfully close to 6, but that's too much. That's too high. So I guess we could say it's $6 and then less, or subtracting 20 pennies. Now, in this case, you can now see how you can use mental math to solve this problem. If we say 4 sets of 6, well, in this case, 4 sets of 6 is going to be 24. But remember, $24, that's too much, that's too much. That was too high of an estimate. Oh yeah, that's right. We're 20 cents too high, and not just one time. For each of those train tickets or whatever, it's 20 cents too high. So 4 sets or 4 groups of 20 cents is 80 cents. Therefore, $24 too high, less 80 cents, $23.20. And yes, folks, if you work this off to the side, should get the same answer. But if you're at the train station, if you are out at the store and you don't have pencil and paper on you, you got to be able to do it mentally. 4 sets of 6, 24, that's too high. It is 4 groups of 20 cents too high. So go down 80 cents and you're at $23.20. Now, as you complete number 18, look how the problems are similar, look how the problems are different, and use these steps to help you out. That's all I have, folks. Take care, do well, and let's grow.